See, class there in this class. Not class, not Next topic is okay. Equilateral, equilateral, lateral triangle, equilateral triangle. Do you know very well this one? Basic point. Basic points. Do you know very well? This is a equilateral triangle. So this is corner having charges Q. This is a Q. At this point, we have to find out electric potential. Electric potential. Distance between charges is A. This is A here. At this point, this is a you take P point. So we have to find out the electric potential at P point due to two charges. Due to two charges. For this one, at this point, do you know point charges? This is a point charge. This is a source charge. Distance from here to here is this is a D. This is a P point. At a P point, electric potential at P point is equal to KQ by D. This is a general formula. Electric potential general formula. General formula. At this point, for this charge, so I am taking V1 is equal to. At this point, what is the general formula? K. Q means at this point we have to find out the electric potential V1, and due to Q by distance between charges is A. Next to E2, at this point we have to find out the electric potential due to the charge, that is KQ by distance A. So we want to find out the electric potential. Electric potential at the P point is equal to V1 plus V2, that is a Vp is equal to KQ by A plus KQ by A. This is a Vp is equal to 2 KQ by A. So Vp is equal to, so 1 by 4 pi epsilon r, so that is a KQ, Q by A, this is a 2 ones to 2 cancel. That is a Vp is equal to Q by 2 pi epsilon r, so that is A. This is the electric potential at the P point. Electric potential at the P point, that is a formula. That is a formula. Okay. So what is this is a formula, first model. This is a first model. Next, the second model. Next, second model. What is the second model? Second model is so Q minus Q. This is a point. Distance between the charges is A. At this point, what is the electric potential? So V1 is equal to V1 is equal to V2 is equal to. What is the V1? V1 is equal to. So V is equal to, what is the V? At this point, the electric potential due to the charge. So V at this point. At this point, we have to calculate the electric potential due to the charge, that is the KQ by A. At this point, we have to calculate the electric potential due to the charge, that is a minus KQ by distance A. So this is cancelled, that is the electric potential at this point is 0. That is the model number 2. So next model. So this is a Q, this is a Q, this is a Q. At this point, midpoint, we have to find out electric potential at midpoint. Electric potential midpoint. Midpoint question mark. So do you know very well distance between the charges is A. So at midpoint, this can be divided into, this is A by 2, this is A by 2, this is Q, this is a Q, This is the distance between the charges is A. Distance between the charges is A. From here to here is the distance. What is the distance from here to here? Distance. This is according to Pythagoras class. What is the Pythagoras class? This is A by 2. This is A. This is I'm taking this part. This is A by 2. This is A. This is the root of A square by 4 plus A square. That is the root of 5A square by 4. That is the root 5 by 2. This is sorry. Wait. This is take part. This is A by 2. This is a part to take out. This is the A point, B point, C point. This is A by 2. This is A. So according to Pythagoras law, AC square, AB square plus BC square. BC square, AC value is A square. AB value is, what is AB value? We don't know. We have to find out. BC value is, what is the BC value? A by 2 whole square. This is the A square. This is the AB square plus this is A square by 4. Take this side. This is the AB square is equal to A square minus A square by 4. This is a 4A square. This is a 3A square by 4. And AB value, this is a take root. This is equal to root 3 by 2. This is a value. So this is the value is root 3 by 2 A. Root 3 by 2 A. Root 3 by 2 A. Okay now. So that is the electric potential at this point. Electric potential at this point due to the charge. So that is the first one. At this point, electric potential due to the charges, that is K cube by A by 2 plus this is K cube by A by 2. So plus due to the charge, that is K cube by root 3 by 2 A. This is the answer for that. Okay. So we are going to simplify. This is so this is a value is K cube. This is 2 by A plus 2K cube by A. So plus this is K cube 2 by root 3 A. 3 A. This one is common. So B is this is K cube by A is common. Okay na? 2Q common. 2K cube common. So 1 plus 1 plus 1 by root 3. 1 plus 1 plus 1 by root 3. So this is okay. Now you can simplify this. Okay. So this is 2. This is 2 plus root 2. 2 plus root 2. That is your answer. That is your answer. Your that is your so next model. So this is an equilateral triangle. So this is Q. This is also Q. This is a minus Q at this point. Relative potential at this point. This is a denote very well root 3 by 2 A. Distance from here to here is A. This is A by 2. This is A by 2. This is A. Relative potential at this point. Relative potential at this point. Relative potential at this point. So V is equal to, this is a P point. This is a V is equal to, this is a Q. At this point, relative potential due to the charge, that is the K Q by A by 2. So at this point, We have to find out the electric potential at this point due to the charge, that is a minus kq by a by 2 plus at this point we have to calculate the electric potential due to the charge, that is a kq by root 3 by 2, and this is a plus k cube a by 2 minus k cube a by 2 cancel each other, that is a b is equal to k cube by root 3a. This is a 2. This is a electric potential at this point. Electric potential at this point. This is your answer. That is your answer. Next. So next model is this is a q. This is a q. This is a q at this point. We are calculating at this point. From here to here is the distance a by root 3. This is a basic point. You know very well. You know, so very well. So what is the electric potential at this point? The distance between the charges is AA. Distance between the charges is AA. Okay, this is now electric potential at this point, center point. Okay, now we are calculating V is equal. At this point, we have to calculate the electric potential due to the charge, that is the KQ by distance between the point charge and here A by root 3 plus this is over. Next, at this point, due to the charge due to electric potential group. Plus at this point we have to calculate the electric potential due to the charge, that is the kq by distance between the two charges is a by root. So this is a v is equal to kq a by root 3 plus kq root 3 by a plus kq root 3 by a. This is a v is equal to 3 kq root 3 by a. This is your answer. Your answer is clear. Now next one is next one. So that is one model. This is next one. So this is plus q minus q. Electric potential at the center point. Electric potential at the center point. This is a minus q. So this is at this point we have to calculate the electric potential root 3 by a plus this is kq root 3 by a minus that is kq root 3 by a by root 3. Sorry, distance from here to here a by root 3, a by root 3, a by root 3, a by root 3, a by root 3 cancel each other. You are getting kq root 3 by a. That is your answer. That is your answer. Okay, now clear. This is one more model. Next. Next, this is a triangle. This is a Q. This is a minus. So go at this point, center point. Okay. So B is equal to this is a KQ by root 3 by A. This is a by root 3. From here to here distance is A by root 3. So plus from here to here is kq by a by root 3. So that is a minus 2q by a by root 3. So this is value is this is a 2kq by a by root 3 minus 3a by root 3. This is a 2k q a by root 3 cancels. Electric potential at center point is 0. Center point is 0. That is a point. This is one. Last question model. Last model. This is x value. This is a q. This is a q. Q and q. Q and Q. So find X value. Find X value. So EC is equal to 0 center point and VC is equal to 0 also. But what is the X value? What is the X? So this is the VC is equal to 0. But what is the X value? So EC is equal to 0. What is the X value? We have to find it. We have to find it. This is electric potential at the center point is equal to 0. This is intensity of electric field EC at the center is equal to 0. But what is the X value? X value. This is a QQ. This is a QQ means this is a minus 2Q means this is a X is equal to minus 2Q. Minus 2Q means so what is a VC? VC also 0. We are finding this is a VC. VC is equal to at this point center KQ by distance A by root 3. From here to A by root 3. So next plus KQ by A by root 3. That is a minus 2KQ by A by root 3. A by root 3 cancel. VC is equal to 0. But X, what is the X value? This is X is equal to minus 2Q. This is an answer. First. Next EC is equal to 0. EC is equal to 0. EC is equal to 0. I'm checking this is Q, Q. I'm taking X is equal to, this is a minus Q. Minus Q, this is a center point. Center point, this is A by root 3. A by root 3, this is a EC at the center is equal to K, Q by A by root 3 whole square plus, this is a KQ by A by root 3 whole square minus KQ by A by root 3 whole square. A by root 3 whole square. Whole square. So this is a KQ. So this is A square by 3 plus this is a KQ. A square by 3 minus this is a KQ. A square by 3. A square by 3. This is a so KQ A square. This is a 3 plus 3 KQ by A square minus this is a 3Q by A square. This is what is the value of this one? This is a cancel each other. This is a 3Q by A square. But EC does not become 0. Become 0. But it's a so this is wrong. This is a wrong. But so we are getting EC value 0. But I'm taking this is a plus Q. I'm taking plus Q. Still I'm getting plus Q means this is a plus 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 we are getting. Now what happened? Okay, plus Q. So what we are getting, you see, so plus Q we are taking. Plus Q I'm taking. So this is a Q. Suppose I'm keeping the test charge. This Q, this is a capital Q, repels the charges this direction. That is the E1 force. This is a capital Q. This is a Q repels this direction. That is the E2. This is a Q. This is a repel to this direction. This is forces. You are seeing electric field E2. This is E1 and this is E3. But E1 is equal to E2 is equal to E3. Both are same. Both are same. Why means the distance between the charges is same. Here is angle is 120. 120. That is E here. This is E. Both are in the opposite direction. E center is equal to 0. Your answer is here. EC is equal to X is equal to plus Q. Plus Q. That is your answer. For this one, X is equal to minus 2. This is important. Important model. Important model problem. Next model, square. Next is square. Next is square model. Do you know very well basics? So this is a square Q charts Q here also. At this point, we have to find out the elliptic potential. Elliptic potential. Distance between square is this is the distance between. And at this point, we have to find out the elliptic potential at this point. This is a point P. So elliptic potential at the point. Do you know one thing? Say, force between at this point K Q square by A square root 2 plus 1 by 2. I think this is a value. So this is the intensity of electrical force by charge is equal to E is equal to F means K square by A square root 2 plus 1 by 2. 1 by 2 by Q cancel. E is equal to K cube by A square root 2 plus 1 by 2. Root 2 plus 1 by 2. This is a electric field. This is a force. We are getting electric potential. V is equal to we are finding V. So V is equal to what we are getting K cube by A root 2 plus 1 by 2. Root 2 plus 1 by 2 your answer. This is a electric potential. Electric potential. How we are going to solve that one means your thing. You see distance from here to here A. From here to here this is a root 2A. Root 2A. At this point, the electric potential at P point is equal to. At this point, we have to calculate the electric potential due to the charge, that is the KQ. Distance between point charge and Q is equal to A plus. Similarly, the charge also KQ by A plus remaining charge. This is the KQ by distance root 2A. So, A. So, VP is equal to KQ by A common 1 plus 1 plus this is a 1 by root. So this is a VP is equal to KQ by A. This is a 2 plus 1 by 2. 1 by root. That is your answer. That is your. This is a root 2. Sorry. This is not correct, ma. This is your correct. 2 plus 1 by 2. That is your. In case second model, next model. This is a square. This is a cube. This is a cube. This is a cube. This is a point P. This is minus Q. I'm taking distance between the charges is A. From here to here is root 2A. This is a A. This is a A. So now electric potential at P point is equal to K cube by A. This is a 2 minus 1 by 2. 1 by 2. This is a processor. Answer this is one. Now at this point, the electric potential at P point due to the charge. K cube by distance between the charge and point is A plus. This is a point. We have to find out the electric potential at this point due to the charge. That is K cube by A minus. This is the K cube by distance root 2A. Root 2A. This is a VP is equal to K cube by A take common 1 plus 1 minus 1 by root 2. So this is a VP is equal to K cube by A 2 minus 1 by root 2. 1 by root 2. This is an electric potential. Electric potential. Electric potential. Electric. That is your. So next model. So next model is this is so Q, this is Q, this is a minus Q, this is a P point. P point. What is the electric potential at point? Electric potential at point. So at this point, what is the electric potential from here to here is to A, here. At this point, so VP is equal to, and this is a minus K cube by A plus K cube by A plus K cube by root 2A. This is a cancel each other. VB is equal to K cube by root 2A. Root 2A, that is your answer. That is your answer. Next model. Next model. This is for homework for you. You can do it for this one. Already I explained this model in electric field and electric potential. So you have to find out electric potential at this. This is a P point. So just to find out from here to here is a distance A, here to here, here. Let's find out. This is homework for you. So next, next, this is a square. Chart is Q. This is a Q. This is a center. So VC is equal to, what is a VC? So what is a VC? Relative potential at the center point. Relative potential at the center. So you see from here to here, from here to here is, this is root 2A. From at this point, that is root 2A by 2. That is, you can write this is root 2, cancel each other. Sorry, cancel each other. That is A by root 2. A by root 2. This is A by root 2. This is A by root 2. This is a center point. Center point. From here to here is A by root 2. From remaining part is A by 2. Relative potential at the center point. At a center point. At this point, so BC is equal to. At this point, we have to calculate the relative potential due to the charge K cube by distance between point and here is 1. 1, 2, 3, 4. 1, 2, 3, 4. Remaining is remaining. For this one, K cube by A by root 2. For this charge, K cube by A by root 2. For this charge, K cube by A by root 2. So how many? 4 into K cube by A by root 2. This is a BC is equal to 4 into K cube root 2 by A. Root 2 by A. This is A. That is your answer. Next, third model. This is a square. Charges is corner of charges minus Q. This is a plus Q. This is a plus Q. So we have to find out the relative potential at the center point. So what is the answer? Your answer is VC. Relative potential at the center point is equal to 0. That is your answer. Let's find out. From here to here is A by root 2. A by root 2. So relative potential at the center point. This is a QQ. So KQ by A by root 2 plus KQ by A by root 2. So minus KQ by A by root 2. So this is a minus KQ by A by root 2. Plus, minus, plus, cancel each other. VC at the center point is 0. It is 0. This is one more. Next model. This is a square. This is a square. This is a plus Q. This is plus Q, minus Q, minus Q. Center point. What is the center? VC is equal to 0. VC is equal to 0. That is a one model. That is a next. This is the next model. This is a square. At this corner, Q, capital Q. This is the Q minus Q plus. Okay. At this point, you cannot put from here to this A by root two. A by root two. So this is so VC is equal to KQ 1, 2, 3. 3 KQ by A by root 2 minus this is a KQ by A by root 2. So this is a VC is equal to 2 KQ A by root 2. This is a VC is equal to root 2 KQ by A. That is your answer. That is your answer. Okay, next model. Important model. Very, very important. Important model. This is a square. This is a square. Capital Q, Q. This is Q. This is X. So EC is equal to 0. What is the X value? And the VC is equal to 0. What is the X value? What is the X value? X value. This is Q, 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 Q. This is X. X is equal to what we are taking. So VC is equal to 0. So VC is equal to 0 means we are taking this is Q, 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 3Q. I'm taking this is we are taking, for example, X is equal to this is X. Q, 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 3Q. So I'm taking minus 3Q means minus 3Q. We are taking how much value we are taking? I'm taking minus 3Q. Minus 3Q. For example, I'm taking minus 3Q. Minus 3Q. So electric potential at where we have to find the electric potential? At this point, where electric potential at center, at a center point, at a center point. Electric potential at a center point, at a center point. VC is equal to from here to here is a distance. This is a by root 2. That is a 1, 2, 3. 3Q by A by root 2. Next minus this is K. 3Q K by A by root 2. Cancel each other. That is a VC is equal to 0 at the center point, and the X value is equal to minus 3Q. Minus 3Q. That is your answer. Your answer. Next, EC is equal to 0. EC is equal to 0 when it becomes 0. This is a square Q. This Q. This is a Q at center point. X is equal to question mark. EC is equal to also 0. But X is equal to what is the value? X. I'm taking Q. I'm Q. So this is a Q. I'm test charge placing here. This Q will repel to this charges Q in this direction. That is the F. This is a Q. This is capital Q. This Q will be repelled in this direction. Both are in the same opposite cancel. This Q repels in each other in this direction. This is Q repels in each other. Both are cancel each other. X is equal to Q. X is equal to minus 3. Minus 3. That is your answer. That is your answer. Your answer. Next is This is square minus q minus q. This is 2 capital Q. This is a 2q. But BC is equal to 0. BC is equal to 0. Find relation between capital Q and small q. Small q. What is the relation we have? What is the relation we have? BC is equal to 2. BC is equal to 2. At this point, this is from here to here is a by root. So VC at relative potential is 0 given. This is a 2q. from here to here is minus q by a by root 2. At this point, plus k 2q by a by root 2. From that point, plus k 2 small q by a by root 2. A by root 2. This is minus kq by a by root 2. A by root 2. So VC, what is given? VC become 0. So VC is become 0 means this is you see, this is a minus kq a by root 2. This is a plus 2q a by root 2. We are going to write that is kq by a by root 2 for this one. This is we are going to write it. This is a plus kq by a by root 2. This is a value is 2. This is a value is 1. This is plus minus. We are getting 1. So this is kq by a by root 2 is equal to minus kq by a by root 2. So this value take this side. Take this side. Otherwise, you take this value. This value take this side. It become minus. So here k cancel each other. A by root 2 cancel each other. Small q is equal to minus 2. That is a relation. Relation between the small q and plus. This is a relation between the small q and positive. I mean small charge and small q and capital Q. That is the relation. That is a relation. Okay, this is you have the square model. Next model. Next model. Next, do you know very well? This is all. This is a polygon. 1, 2, 3, 4, 5, 6. Hexagon. This is a hexagon. Q charge Q, 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 here Q, here Q. Here Q. At this point, what is the point? BC. What is the BC? At this point, BC, distance between here A and remaining all are A. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 into kq by A distance. That is here. But EC is equal to 0. Electric is 0. That is one model. This is a form. This is a minus q, minus q, minus q, plus q, and this is a plus q, a plus. 3 charges are positive, 3 charges are negative at the center point. Electric potential at the center point is 0. So VC is equal to VC is equal to. So minus 3 minus 3 kq by A plus 1, 2, 3. 3 kq by A. This is cancel each other. VC at center point is 0. Center point is 0. Center point is 0. So this is the point Q at a BC 1, 2, 1, 2, 3, and this is also 0. Multiple potential at 0. So next this point minus q, minus q plus q. So VC at 0, but E not equal to 0. Okay, that is your answer. One answer. Next last model. This is a hexagon. Next cube model. This is a cube. This is a cube, and charges are placed at corners of the cube. And the center point at the center. So BC is equal to EC 0 BC. But so what is a BC? From here to here is the distance. This is the root 3 by 2 a. Root 3 by 2 a. So this is 1, 2, 3, 4, 5, 6, 7, 8. Total how many? How many charges we have? This is 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 cube by root 3 by 2a. So that is a BC is equal to 8 into 2 into k cube by root 3. Yeah, this is a BC is equal to 16 k cube by root 3. Yeah, this is your answer. So VC is equal to 0. This is over. Topic is over. That is a model is over. Next topic is ZPP. Next ZPP. ZPP 0 potential point. Okay. The point which the resultant electric potential, the point which the resultant electric potential is 0. The point at which resultant electric potential is 0 called as ZPP. So at ZPP means 0 potential point. So electric potential is 0, but electric field is not equal to. At neutral point, electric potential not equal to 0. Electric field is 0. Okay. The point which the resultant electric potential is 0 called as ZPP. At ZPP, V is equal to 0, E not equal to 0. At the NP, V not equal to 0, E is equal to 0. E is equal to 0. equal to 0. In case of like charges, like charges, ZPP does not exit. Does not exit. In case of like charges, ZPP does not exit. In case of unlike charges, number of ZPP in the field in the field is infinity. The field is infinity. The field is infinity. The field is infinity. This is a minus q. This is a plus q. This is a dipole. Distance between is 2a. This is an equalator line. Equalator. This is a point P. This is a minus q. This is a plus q. At this point, the relative potential P point is equal to minus q by distance from here to is a. This is a r. This is a root of a square plus r square plus. That is a k cube by root of a square plus r square. So what is a VP 0? VP 0. This is a first point. Second point. This is a third point. Third point is in case of equal unlike charges, all points on the equipotential on the equatorial. In case of equal unlike charges, all points on the equilateral potential is 0. All points on the equilateral potential is 0. All points on equatorial potential is 0. Potential is 0. That is very, very important. Every point, all points on the equatorial line is ZPP. All points are every point on the equatorial line is ZPP. ZPP means zero potential point. So this is a minus q, this is a plus q, this is a minus q plus q, this is a minus q, this is a plus q, this is actual line, this is a midpoint. Some midpoint at here ZPP exists. This is in case of equal unlike charges along the line ZPP is formed at midpoint. So this is a zero potential point. The point at which the resultant electric potential is 0 is called as ZPP. At ZPP, V is equal to 0, E not equal to 0. At NP, neutral point, V is not equal to 0, E is 0. In case of like charges, ZPP does not exist. In case of unlike charges, number of ZPP in the field is infinity. This is in case of equal unlike charges, every point in the equilateral line is ZPP. So midpoint is exit. Next one. Next one. Next one is, we know neutral point. Neutral point. Null point or neutral point. Neutral point. This is a Q1. This is a Q2. Distance between the two charges is a D. From here to here is a null point is formed at x distance. This is a D minus x. D minus x. Q1 less than Q2. Q1 less than Q2. That is a x is equal to a D by root of Q2 by Q1. Q2 by Q1. Q1 is inside. Q1 is inside from Q1. Inside from Q1. Q1. So next, suppose for example, so ZPP is formed formed inside charges. This is a one ZPP is formed. One ZPP is formed. One ZPP is formed. So next, this is a Q1. This is a Q2. Distance between charges is a D. This is a point. From here to here is a distance x. From here to here is D plus x. D plus x. Q1 less than Q2. Q1 less than Q2. Here, x is equal to null point from Q2 by Q1 minus 1. Minus 1. This is outside from Q1. Outside from Q1. So ZPP is formed from outside the charges. Outside the charges. Here finally two ZPP form. This is a ZPP1. This is a ZPP1. Zero potential point. Zero potential point is formed between. Zero potential point is formed right outside the charge. Outside the charges. So this is the next equipotential surface. Next topic is equipotential surface. Potential surface. This is EPS. It is denoted by EPS. Okay. Okay. And the time is okay. Tomorrow I will explain this topic more. Thank you very much. Time is